Okay, Watkins. So we're on journal page 36, solving quadratic equations by taking square roots. Example 1, solve the equation x squared minus 8 equals 41 by graphing. Step 1, graph y equals x squared minus 8. Step 2, graph y equals 41. Step 3, identify the x coordinates of the points where the two graphs intersect. So we're going to go to Desmos. Let's graph x squared minus 8 and y equals 41. Okay, now we're going to need to zoom out. Here's our intersection. So our solutions are negative 7 and 7. All right, go ahead and finish up example number 1. All right, example 2, solve x squared minus 8 equals 41 by factoring. All right, so first off, we need to subtract 41 from both sides. X squared minus 49 equals 0. All right, so now we know 2 parentheses makes x squared. So x and x. Now, I'm going to rewrite x squared minus 49 as x squared plus 0x minus 49 equal to 0. And the reason being is we need to figure out what number multiplied to give you negative 49 combined to be 0. Okay, so let's try negative 1 times 49 equals negative 49. Negative 1 plus 49 is 48. That doesn't work. Negative 2 doesn't work. Negative 3, negative 4, negative 5, negative 6, negative 7. So negative 7 times 7 is negative 49. Negative 7 plus 7 equals 0. We have our negative 49 or 0, so our factors are x minus 7, x plus 7. Okay, almost forgot. Equal to 0. So x minus 7 equal to 0. X plus 7 equal to 0. Add 7 to both sides. X equals 7. Subtract 7 from both sides. X equals negative 7. All right, go ahead and finish up example 2. All right, example 3. Solve by taking square roots. So we're going to add 8 to both sides. So x squared equals 49. Take the square root of both sides. Remember, square roots plus or minus. Cancels. You're left with x equals plus or minus 7. So x equals 7. X equals negative 7. All right, go ahead and finish up example 3. All right, example 4. Solve the quadratic equation by taking square roots. It appears my example is missing an equation, but I'll write that in. X squared equals 45. This should be on your paper. Divided by 9. Okay. Now, first things first, we can actually divide 45 by 9. Okay. So let me go back here. Scientific calculator. 45 divided by 9 is 5. Okay. So let's rewrite this as x squared equal to 5. Take the square root of both sides. Plus or minus. Cancels. X equals plus or minus the square root of 5. So x equals the square root of 5, and x equals negative square root of 5. All right, go and finish up example 4. All right, let's take a look at example 5. All right. Now, first things first, we need to subtract 20 from both sides. So then you get negative x squared divided by 4 equals negative 20. Now we need to get rid of the fraction, so we're going to multiply everything by 4. So 4 times, that's negative 4x squared divided by 4 equals negative 20 times 4 is negative 80. This divided becomes 1, so you get negative 1x squared equals negative 80. Divide both sides by negative 1. So then you have x squared equals positive 80. Take the square root of both sides. Okay, so plus or minus square root of 80. So that cancels. You get x equals plus or minus. Now, we need to try to reduce it. So we need to try to find a perfect square that goes into 80. So let's look at 1 squared. Now, we can do 80 divided by 1, but that doesn't do anything. Okay, let's try 2 squared. Okay, is 4. Let's try 80 divided by 4. Now, we have 20, and that might work, but let's see if we can get the number reduced some more. Okay, so now let's try 3 squared. 80 divided by 9 is not going to work, so now let's try 4 squared. 16. So now let's try 80 divided by 16 is 5. So that's what we want to do. Okay, so we want to rewrite 80 as square root of 16 times 5. Now we can take the square root separately, so that's equal to plus or minus the square root of 16 times the square root of 5. Well, the square root of 16 is 4, so x equals plus or minus 4 square roots of 5. And we could write it separately, but we can actually just write it like that. Okay. All right, go ahead and finish up example 5. All right, example 6. Solve the quadratic equation by taking square root. So first thing first is we're going to add 8 to both sides. So that becomes 0. You get 3x squared equals 40. Divide both sides by 3. That divides becomes 1. You get x squared equals 40 divided by 3. Okay, take the square root of both sides. That's plus or minus. So that cancels. You get x equals plus or minus the square root of 40 divided by the square root of 3. Now, you can't have your final answer with the square root in the bottom. So what we're going to do is we're going to multiply this by the square root of 3 divided by the square root of 3. Okay, and the reason we're going to do that is, let me clear this out. First off, the square root of 3 divided by the square root of square root of 3 divided by the square root of 3 is 1. Okay, so we're not changing the equation. But the reason we're going to do that is because the square root of 3 times the square root of 3 is 3. Okay, so now whenever you multiply square roots, you multiply the number inside the square root. So it's still plus or minus square root of 40 times 3 is 120. But now square root of 3 times square root of 3 is divided by 3. But we need to see if we can reduce the 120. Okay, so that equals plus or minus. Let's see if we can find two numbers that can, one of which being a square, can reduce it. So we're not going to bother with 1 squared. Let's try 2 squared. Okay, it's 4. 120 divided by 4 works, but that number's still big. Let's try 3 squared. Not 27, I don't believe goes into 120, but we can try. Divided by 27. Nope, that doesn't work. So now let's try 4 squared. 16. Let's do 120 divided by 16 is 7.5. That's not going to work. So let's try 5 squared. 25. 120 divided by 25. That's not going to work. So let's see. 6 squared. 36 is not going to go into 120, but we can try 120 divided by 36. Nope. 7 squared. 49. 120 divided by 49. Nope. 8 squared. 64. 120 divided by 64. That's not going to work. 9 squared. That's definitely not going to work. 10 squared. 100. 120 divided by 100. Nope. 11 squared. All right. Once you've gone past a number, then you've gone through all the combinations work. And the only combination that worked was 120 divided by 4 gave us 30. Okay. So I can rewrite this as 4 times 30 divided by 3. Now, square root of 4 is 2, so our final answer is plus or minus 2 square roots of 30 divided by 3. So x equals plus or minus 2 divided by 3 times the square root of 30. All right, go ahead and finish up example 6. Let's take a look at example 7. Solve the quadratic by taking square roots. Allow for imaginary solutions. So we take the plus or minus square root of both sides. Okay. So that cancels. X equals plus or minus the square root of negative 16. But that can be written as plus or minus the square root of negative 1 times the square root of 16, which equals plus or minus the square root of negative 1 is imaginary. Okay, square root of 16 is 4, so that's times 4. And then we're going to rewrite it as plus or minus 4. You must always put the number in front, so plus or minus 4i. Okay, go ahead and finish up example number 7. All right, let's take a look at example 8. Solve the quadratic by taking square roots. Allow for imaginary solutions. So we subtract 25 from both sides. So then you get x squared equals negative 25. Take the square root. Remember, square root is plus or minus. Now, we know from the previous example that we can just go from this to writing that as plus or minus 5i. All right, let's take a look at example 9. Okay, so we add 9 to both sides. You get 21x squared equals 9. Divide both sides by 21. That divides becomes 1. You get x squared equals 9 divided by 21. Take the square root of both sides, plus or minus. So then x equals, now we write that as plus or minus the square root of 9 divided by square root of 21, which is plus or minus the square root of 9 is 3 divided by the square root of 21. Now you can't have square roots on the bottom, so we need to multiply this by square root of 21 divided by square root of 21. So that's plus or minus 3 square roots of 21 divided by 21. Now, 3 divided by 21 reduced to be plus or minus 1 square root of 21 divided by 7. Which really you can just write as plus or minus the square root of 21 divided by 7. All right, go ahead and finish up example 9. Now, we're saying the solutions are real because there's no imaginary, okay? All right, let's take a look at the next example. I believe it's the last example. Example 10. Determine whether the quadratic equation has real solutions or imaginary solutions by solving the equation. Okay. So first things first, we need to distribute the 6. So that's 12 x squared minus 24 equals 5x squared minus 40. Now, whenever we have x squared on both sides, we subtract the smaller one from the larger one. So subtract 5x squared from both sides. So then you get 7x squared minus 24 equals negative 40. Add 24 to both sides. You get 7x squared equals negative 16. Divide both sides by 7. You get x squared equals negative 16 divided by 7. Take the square root of both sides, plus or minus. So x equals plus or minus the square root of negative 16 divided by the square root of 7, which equals plus or minus, the square root of negative 16 is 4i divided by square root of 7. You can't have a square root in the bottom, so we need to multiply this by square root of 7, square root of 7. So that equals plus or minus 4 square roots of 7i divided by 7. All right, so x equals plus or minus 4 divided by 7, square root of 7. So the solutions are imaginary. All right, go ahead and finish up your examples. Start working on time and have a wonderful Wildcat day.